All right. Awesome. Thanks everybody for being here today. I get a chance to talk about one of my favorite topics, and that is intentionality. And I'm explaining what that means, how it'll bend back to architecture and design. And I was just really thankful for Aaron's keynote this morning, because I thought he really laid the inspiration. And I'm hoping to bring the framework of how you can take some of the things that he inspired you to do into action to be successful. But first, I want to explain why I think you should be here. I mean, you're already here, so thank you, but why I think you should care about this topic. And it's because I firmly believe that being able to explain why a system works and what it's trying to do is the fastest way to becoming a senior engineer. So after you get in through the door, the fastest way to progress through your career is to develop and work on your ability to explain why a system works and to understand how a system works. This is more important than learning another new language, more important than another new library, more than studying algorithms even. I think this is going to be something that you want to put in your tool belt as early as possible and start practicing. Conversely, and this is really kind of more of a recent thing, being unable to do this and unable to develop the skill or unwilling to develop this skill is one of your biggest risks to being left behind in this new sort of AI-fueled job market. If we believe that humans will remain in the loop with AI, the thing that we are meant to bring is our intuition, our discernment, our understanding, our wisdom. That's what we're there to do. If the only thing that you're honing is your ability to sling code, then I hate to inform you that AI will catch up with you eventually. As I was preparing this, I saw this talk recently, which I love because I think it does encapsulate so much of what we're going to be talking about. And it was by Dexter Forthby. And he said, a bad line of code is just a bad line of code. But a bad part of a plan can be hundreds of bad lines of code. And a bad line of research, a misunderstanding of how the system works and how data flows and where things can happen, could be thousands of bad lines of code. And you can put in parentheses here, a bad system prompt, a bad rule could produce hundreds of thousands of bad lines of code. So yes, the code is important and it has to be correct, but you can get a lot more for your time by focusing on specifying the right problem and what you want. So we'll circle back, introduce myself. Hi, I'm Rob. I'm VP of Innovation at This.Labs. Got almost 2 decades of experience professionally being a developer. I host the Modern Web Podcast. You can follow that link there if you haven't listened to us before. If you follow Tracy online, you've probably seen my face once or twice. And I have some hobbies. Now, let's get started. An email arrives in your box. Maybe it's happening to some of you right now, and you're working on it. You've just been assigned a new bug, a new issue has just emerged. What is the very first thing you do? Roll your eyes. Again. What's that? Reproduce it, yeah. So maybe the first thing is you recreate the issue. Make sure you can see the same thing that the testers saw. Maybe you just start debugging, just getting data. Go get log files, get as much information. You're going to need it later anyways. Or maybe you write tests. You go, okay, well, if I can write a test, obviously a test didn't catch this bug, so I'll write a test that'll catch the bug, and then I'll know when I fixed it. Now, is there anything else? And I would argue that there is something that you should do even before any of these things, and that is that the first step towards fixing a bug is to understand what the system is supposed to be doing anyways. How many times have you opened up a bug and what you realized was, that's not a bug. That's just how you want the system to be. It's doing exactly what it's supposed to be doing. You just happen to not like that. That's a feature request, right? Or maybe they misunderstood the requirements. Or maybe it is the case that the requirements are wrong. And what you need to do is not just fix a bug, but you need to get a group of people together and fix the requirement and then figure out how that requirement change is going to propagate through your whole system. So don't start working until you actually understand what it is you're working on. And that explains a little bit, or at least as an intro to how I once earned my salary in a single day. So I was joining a new team and I was going to be the tech lead, but they said for a couple of sprints, why don't you just work some tickets? That way you'll learn the process, you'll learn what the system does, and then you can kind of graduate into more leadership roles. And I said, that sounds great. So I took a ticket and it was for a shipping module and sort of a larger product suite for like running businesses. And it had a professionally done UX flow. It had a UI design that were all approved by the client. It had a set of requirements that were developed by a professional business analyst, and again, approved by the client. Now, one would think all I had to do was code it. Now, my dad has a family business, and I didn't work in the shipping department, but I knew a little bit about how it worked. And as I read the requirements, something didn't seem right. It just didn't seem like it was going to work. So I took it to my manager and I said, I know what I'm reading, but it doesn't seem to make sense. And so we went back and they looked at the notes and they said, no, you can see here in the notes from the client, that's exactly the way they want it to be. But I agree with you. It doesn't seem to make sense. So we went back to the original interviews with the user, videos we had taken where they showed us how the current system that they used worked. And sure enough, it was not going to work. And what had happened was what had become the requirements was what the boss wanted the process to be, not what the process actually was. And that sort of telephone game had produced this issue. Now, what happened was I didn't develop that feature that way. We solved it then. I didn't spend the time developing it, then us spend the time testing it, then releasing it, giving it to the client, them aiding it, putting an emergency ticket because their shippers can't ship things properly. Us have to solve it under duress, repatch it, refix it, retest it, and resend it out. Stopping for a second up front and asking, does this make sense at all? Was the key to saving tens, if not hundreds of thousands of dollars. Software is expensive, y'all. And so any amount of due diligence, any amount of intentionality you can have up front can save so much time and money. So that leads us to what I keep saying this word, intentionality. How do I define it, and how should you understand it, at least for the purposes of this talk? Intentionality is the process of understanding for every unit of code, every team process, every task that you do, not just at work. You can take this into life as well. You ask yourself, why am I doing this? Know your why. What can I understand and agree to be true of the things that people will give me as the inputs to this? This can be the arguments to a method, the inputs to a module, or it can be the requirements I receive. What do I know about them? What can I assume to be true about them? And what should I hold those people responsible for? What should be true of the things that I give back out? True of my return values? What are people expecting of me? And what expectations do I have to meet? What do I want this to do and how should it work? Not how will it be implemented in code, but what are the elements of the solution that I want to be there? Do I need to talk to certain systems? Do I need certain amounts of security? What are the things and the ways I want it to behave? Also, what kind of things should be defined or left undefined? You might feel like, as a developer, and I get in these conversations all the time, right? We love finding edge cases. We love solving every conceivable condition in the universe, but great swaths of them don't occur in normal life. And so sometimes you don't have to solve those problems. So deciding what you're going to focus on and what you're not going to focus on can be intentional as well. And it's important to note here, especially if you're a junior, you might be saying, Rob, I get that, but I don't know that I'm right. Being intentional does not mean you are right. Sometimes you will not know what you're doing. I don't know what I'm doing at all times. But the point is that if you are intentional, you will just not have mistakes. You can only have things that you will, are lessons to be learned, right? So you won't have, you're not going to be perfect, but you're going to have mistakes that cause you to have learnings to be better in the future. And that's what this promises us. So what does low intentionality sound like on a day-to-day basis? You might have heard some of these things on your team. It sounds like, hey, I don't know, seems to work, right? This leaves you vulnerable to half fixes or regressions. I had this once. We couldn't solve this one problem. Everybody's done this, right? Well, maybe not nowadays. Now it's ChatGPT, but at the time it was Stack Overflow. Found a piece of code on Stack Overflow. We just pasted it in, fixed the problem. Seems to work. We don't know why, but it seems to work. A couple weeks later, we were testing for a release, and we had this really hard to reproduce but persistent crash due to a timing issue. We could not figure out what it was, and eventually we figured out it was this line of code we had just copied from the internet. We finally figured out what it did do and realized that it caused other issues that were far worse than the problem it solved, and we actually solved the problem for real. It sounds like, hey, I did what the ticket said, right? This is kind of like the story I said. Don't sacrifice your agency. You are responsible for delivering the best for your users, for your customers, for the people in your life. You can't hide behind somebody with more seniority said to do it. Somebody else being paid more than me said I should be doing this. You are responsible for understanding what you're doing and putting forth the best work for your clients. Or maybe, I didn't know that was used there. This one comes up a lot when somebody has written some code that they intended to be used within their own module, and you, being the responsible engineer that you are, said, I just want to not rewrite code. So you go and you find a piece of code that does sort of the stuff you wanted to do. And you go, okay, I'm just going to use that. But that code wasn't meant to be used by you. It was meant to be used in that module. And so when that person comes back and changes the way that their module works, they didn't know they were breaking your code. So this is low intentionality because, yeah, we were trying to do the right thing, but we used something that was not intended to be used in that way, and we didn't bother to update anybody or inform them that that was happening. So one of the ways that we demonstrate intentionality in work, and it's sort of, you saw this maybe in the talk title, and maybe that's why you're here, is through the idea of software design. This is where we communicate to others what our intentions are and that we understand what we are doing. And so some of the things which is sort of like high intentionality is you start to show to people that you know what your user needs, that you know how the system should act, you know the context into which the solution fits, you know how you build it, and you know the alternatives that you're not going to implement and the trade-offs. So the overall objective of this, of why we write designs and why and how we demonstrate intentionality, is to prove to a context-aware third-party dev that you're building the right thing, you're building it the right way, and to a lesser extent that you know the answers to their questions. And let me explain a little bit of each of those things. So why context-aware dev? We need to assume that the people that we're communicating with at least have a basic understanding of what we're doing. We are not trying to bring laymen or non-technical people all the way up to speed. That's just too much work. But you need to understand that you're communicating to your team. Your team knows many of the things you know, and some things they do not. So you want to bring someone that's mostly up to speed through to this understanding. You want to make sure that you're building the right thing. In other words, you're solving a problem that needs to be solved, and you're actually solving it. You need to show that you're building it the right way, meaning that you not just solve the problem, but you solve the problem in a way that doesn't hurt the system in other ways. And we'll talk more about this. And lastly, that you know the answers to their questions. I don't want to steal a joke I have later, but many times when you talk to somebody about what you want to do, the answer they have is, well, that's not how I would do it. And you want to show that you've already thought of the thing they're thinking of, but that's still why you went the way that you went. All right, this is the template that I have developed for my team. Linda knows this design template. Yeah, she's been using it for years. It's awesome. And you don't have to do exactly this. These are just a set of things that I have found useful over time. As I will say many times in this talk, you just simply need to do whatever works for you where you are. And if you keep following the processes the way I'm going to say, trust me, you will eventually have a more rich and a larger and a more complex design process that you follow over time, and it might look a lot like this. I'll share this template on Twitter after the talk. So the first part of the design that I think is to first admit that the thing that we are not trying to do is prove that we are smarter than people. A software design is not a way for us to brag about how good we are and how bad the rest of our team is because they can't understand our brilliance. It's to have a shared understanding. And so we first start humbly by sharing terminology. What are the acronyms we're going to use? What are the terms? What are the third parties? What are the things that my team might not know or might need defined so that we have no confusion, no ambiguity? Listen, use the best, most complicated, most precise terms you want. Use the precise names of software design patterns. That's fine. But bring people with you. Explain them. And if you don't know what to put in this section, that's fine. But when somebody comes to you and says, I don't understand what this word means, add it to the section so the next person understands. The next section is context. Context is anything external to the code and the system that's relevant to the design. How did you know what problem you needed to solve in the first place? How did you decide what solution you were going to have, right? This is any emails, meeting notes, conversations, videos, UI, UX design, sample data, anything that informed what you were going to solve and how you were going to solve it. Make it available to people here. Don't put all the text in maybe, but like links to it. Where can people find it? You want people to be able to see what you intended to do, what your understanding of the problem was, and sometimes they need to go back to the original documents because they might say to you, hey, I don't think you fully understood what they were saying. And of course, in a design, I think most people are like, a design, that's just like requirements, right? And like maybe some text. Requirements are a big part of a design. And I want to talk a little bit about a couple different things about them. First is, I believe that what you want to put in your design is a minimal set of requirements that must be true of all software that fulfills a user need. And that maybe doesn't sound as profound as it should be to you. I won't make anybody raise their hand, but I'm assuming there are some people in here that still sometimes struggle with the idea that when you have a set of requirements, that defines a single piece of software that meets those requirements. I talk to people about this all the time. They get confused. They're like, I can't see the one system I need to build from these requirements. I'm building the wrong system. You need to see requirements as sort of a bounding set. There are infinitely many softwares that can meet a set of requirements. You can use different languages, different libraries, different approaches, different algorithms, different whatever. You just need to pick one of them. And so in the requirements section, you need to tell people this is the minimal set of things. If you develop any piece of software that meets these requirements, it will meet the business need. And if it doesn't, it won't. That's the perfect set of requirements. You want to avoid having requirements that overspecify, meaning that it constrains you unnecessarily to things that are actually superfluous. So functional requirements define what the software has to do. Those are the things it has to fulfill. And non-functional requirements sort of describe how the software will perform those things. In other words, how well it will do it. These are also sometimes called the ilities. So scalability, maintainability, modifiability, compatibility, performance-ability. These are the hows. And all requirements need to be clear and measurable. What does that mean? It means that you can't say one of the worst and most commonly misused requirements, the system's got to be easy to use. What does that mean? The system has to be fast or responsive. What does that mean? How will anyone know whether you've satisfied that or not? A good requirement is one in which two people looking at a system cannot be confused as to whether the system satisfies it or not. That's the level of unambiguousness you need to have. And lastly, don't just describe how the system behaves now. If you are writing requirements after the fact, don't just describe what the system is now, because you can only ever then validly produce exactly the system you built. Why is that important? It's important because at some point you may want to refactor your system. You may want to add a new feature that's going to change a little bit how this module you're about to build behaves. And if you've written your requirements such that the only valid solution is exactly the one you built, you won't be able to accommodate that request. So make sure you have that minimal set. The next one is the architectural impact analysis. Sounds super fancy, but what it means is that you understand your code is going to go into an existing system. And so you're going to explain and demonstrate to somebody that you understand where that code is going to go and how it's going to impact that system. So you're going to say, hey, in what ways does what I'm about to do harmonize, right? I'm about to add a security feature to my authorization system. That's security going into security, right? That's great. I'm doing the things the module that I'm affecting wants to do. I'm adding to it. I'm enhancing it, right? Maybe the system that you're building in also has a big thing about maintainability on your team for whatever reason. And you go, this is how what I'm going to do satisfies that architectural goal of maintainability. So how do you harmonize with the parts that you're going into? But maybe how does it disrupt? Listen, maybe you're going to go add security features to your high performance module. Performance and security run at odds with one another. You need to show that you're being intentional about where those trade-offs are going to be. You can't get both for free. They have to trade off with one another. Say that that's a thing that's going to happen and explain where you think you're going to draw the line so that other people can evaluate where you decided to draw those lines. And lastly, recognize that you don't just impact code. You also are part of a company. You're part of a team, part of a product. You're going to potentially affect other people. So will what you're doing cause additional DevOps work, new systems to be brought online, new processes or teams that need to be created? Does it require standards work? Will it maybe block another team from releasing over a period of time? Show that you also understand how your code and what you're working on is going to impact other people. Again, so that other people can assess that and help prepare people for that. All right, that was a lot of setting the stage, and we haven't even said what we're actually even going to do. At this point, we could hand off this design to somebody else and they could figure out what to do, right? We've given them all the tools to come up with the solution. They just need to come up with the solution, but now we get to do it. And we're going to start that with the behavioral specification. So again, we're not talking about code yet, but we're going to document all the ways the system can be interacted with and how it will behave. So this is how the user would experience it, not how the system will experience it. So the user pushes this button and this happens. The user pushes this button in this state and this other thing happens. Again, we're not talking about code. This will be the contract that the code has to fulfill. You're just demonstrating and walking through all the cases and how you want to handle them. These become your test case checklist items, okay? I was on a team once, and this is what we did. We basically set up all our test cases before we wrote any code. After we wrote the code, we came and edited the test cases a little bit, update how the UI actually functioned, how you got from step A to step B. But that was our checklist of all the functional tests we wanted to create, was this behavioral spec. This is also where you can find where there's maybe gaps in your understanding of implications. Somebody can say, hey, you're forgetting about this edge case. Course design specifics. Lay out in as much detail as necessary how you're going to implement your solution. Think about potentially how you might give this to somebody else to actually do the coding part. What might they need to know? What patterns will they need? What modules might they need to create? Libraries, how will they manage their data? APIs, contracts. You can decide how deep you need to go, both for yourself, for other people to understand what you're trying to do, and for you to have the most success in working out potential issues before you get there. This section can be very small at first. Again, as you discover that you need to put more detail in there, then let it grow naturally. Don't force yourself to write 50 pages and specify absolutely everything. You may take completely the joy of coding out of it for you. Find what works for you, build up to what works best for you long term. Now, as I said earlier, this often happens, right? People probably get this in the code review, right? One of the first comments you see show up on a code review, other than looks good to me, is maybe, why did you do it that way? I wouldn't have done it that way. Have you thought about doing it the way I would do it? So that's why we document the alternatives in the design as well. So for every choice we didn't make, let's try to document it and justify why our choice is better. If our decision was arbitrary, it's okay to say that. You can say there were 3 choices. I didn't know which one to pick. I just picked one. That's good. Then somebody understands the level of conviction you have in your choice, and they could maybe suggest something different. When people understand the decisions that you make and how you decide them, they can say, listen, I don't agree with the way that you evaluated those options, or I didn't agree with the way you scored one of the choices. Or they might say there was an option you didn't consider that I think would have scored higher. You can start to see we're having better conversations, less about what I prefer and what I would do, and more about these are the rules of the road that we agree that we want to follow, and I just think you didn't apply them well. Much better, more collaborative things. So this could be an example here at data management. So like maybe I consider using context or Redux. And in context, yeah, it's using built-in React tooling. It'll handle my simple case well, but the rest of the app is already using Redux, and there are some side effects that I might need to have to handle. So that's maybe a downside. For Redux, like, does the side effects good? And at least somebody that reads the app will see we're using the same thing everywhere. But the boilerplate can be confusing, and it's overkill for my simple feature. But I'm still going to choose to use Redux because I value consistency. That was how I made my decision, and that's why I'm deciding to do that. And the side effects can be tricky, and I'd much rather implement it more simply. This is an example of how you can show that. So obviously a reminder that when it comes to design decisions, there's seldom an obviously correct answer. As I said before, there are infinitely many systems that meet a set of requirements. So focus on justifying your selections and by referencing the earlier material. Why did you make those decisions? Not because of your personal preference, not because you read it online, but because of something you already put in the design elsewhere that led to that. Okay, so you finish your design, what's next? Obviously implement your design. You want to keep notes. How did it go if you can't remember? And then after the release, when things have calmed down, go back and look at it and say, where was I right? Where was I wrong? And where was I really wrong? And how would I like to do this process differently in the future? It's not about regret. It's not about fixing the problem you already solved. It's what could make me successful on the next design that I do. Is there a section I need to do? Do I need to do something differently? This is part of an iterative process. You're almost there. It's part of an iterative process of improvement. This is why I think it goes really well with what Aaron was talking about today. About planning, doing something intentionally, then executing on it, taking some notes or some data, then reviewing those notes and that data and incorporating it into a better plan in the future. This is how you get better over time. I don't know if Good Place still plays these days, but you too can become Maximum Derek through this iterative process of constantly reincorporating new information into your next iteration. So in conclusion, why is intentionality a superpower? First of all, you get fewer critical structural defects by thinking through the hard problems early. Secondly, because every mistake is a learning opportunity. You get out of the blame game and you get into this idea of, wow, we were all trying to do the right thing. We followed the plan. The plan just didn't get us there. How do we make a better plan in the future? It's a much more collaborative, much less fight-driven type of thing. Less ego. It's easier to collaborate with other developers because, again, you're being so clear about the decisions you make. And anytime you're reviewing something for somebody else, you can always go back and see why they made those decisions. Code reviews get easier, code gets easier, meetings get easier, all of that. You can also develop code faster, especially with AI. All the things and the ways that you're going to describe things in a design that make it easy for humans to understand, AI really understands it. And it helps you reduce hallucinations and get a lot better code out much sooner. And you get caught up less often on syntax errors and byte coding. So final takeaways, commit to doing these things, and I promise it'll do good things for you. First of all, commit to no magic. Never commit new code that you don't understand how it works. It's fine to test things, but once you tested it before it goes to production, take the time to understand it. Always plan before acting, even if you only have time to write a paragraph of what you're planning to do. Just commit to it up front to stop yourself from cheating afterwards and saying, oh yeah, that's what I wanted to do the whole time, right? Put it down on paper so that afterwards you actually have something to review. Quid pro quo, help each other grow. Solicit reviews from other people to improve and review their stuff. This is how we help each other. I show you what I've learned, you show me what you've learned. That's how we collaborate and grow. And lastly, solve first and code later. Too many people get way down in the weeds and they ask, like, I need to figure out how to do this syntax thing in this language. The first question is always, why do you want to do that? Well, because I need this feature. Why do you need that feature, right? Start with the what problem you're trying to solve. Let that trickle down to syntax. Don't get so bogged down immediately into syntax. All right, thanks everybody. It was a lot. That is the slides. And as I'm closing out, I would just remind you that Danny's team and I would appreciate any sort of feedback. So if you go to the schedule again, you can click on the session, you can leave some feedback, your thoughts on it. And I think later that's also where you can get another link to the slides and the recording as well. So have a great one.